Hi, I'm Leslie Mueller. Welcome to Museum Access, the show that takes you to America's top museums to talk to the experts. Then we go behind the scenes to learn even more. Today we're in Albuquerque, New Mexico, at the National Museum of Nuclear Science and History. It's affiliated with the Smithsonian and serves as America's resource for nuclear science and history. Besides the fascinating indoor exhibition areas, there are 9 acres of outdoor space called Heritage Park, filled with military aircraft, vehicles, missiles, and more. Today we're going to learn about the scientific, historic, and cultural aspects of the atomic age, beginning with the Manhattan Project and the American-led effort to develop a functioning atom bomb during World War II. Then we'll see a 42,000-pound hydrogen bomb, the Mark 17, and go behind the scenes to learn more about an incident referred to as Broken Arrow. It created a 12 by 25-foot crater not far from here. So are you ready to join me on America's journey into the age of nuclear technology? Let's go. I have to say, this is one of the cooler museums we've been to. Tell me about it.
Oh gosh, so our museum, the National Museum of Nuclear Science and History, we tell the story of the atomic age, from early developments such as the Manhattan Project and Cold War, to today's peaceful uses of nuclear technology, such as nuclear medicine and nuclear energy.
People forget, don't they, that there are peaceful uses now?
Very much so. So that is something that oftentimes people might say, oh, it's the bomb museum. And
Ooh.
though we have a lot of military background, a lot of weapons, Fat Man and Little Boy, things such as that. We tell of all of the uses. So in today's society, nuclear medicine, nuclear energy, power plants, things like that are so pivotal to who we are and where we're going. So we tell the story, and we oftentimes tell people we're a place to come to learn, think, imagine, and draw your own conclusions.
Oh, that's wonderful. And you talk about learning.
Yes.
I see a lot of children here.
Oh,
Tell me
yes.
what kind of programs are available.
So we are a nuclear museum. We are America's resource for nuclear science and history, but STEM education is huge for us. So whether it's programs, family programs and events that we have throughout the year, or camps where we invite kiddos, so students of younger ages, to come and become engaged in science, technology, engineering, and mathematics.
It's all experiential, isn't it?
Very much. We are huge on hands-on, engaging programs and information where kiddos can really absorb it in a fun and interesting way.
Well, I saw something with splitting an atom, and it was something about you tapped on the floor.
Yes.
What was that?
So that's actually one of our very interactive exhibits. So you have atoms that are projected from the ceiling onto the floor, and kiddos, or really anyone of any age, can go in. We have multiple people of multiple backgrounds and ages coming and splitting atoms. When you step on them, it will split in order to find out, can you provide enough electricity for a nuclear power plant to electrify, to actually provide electricity for a city.
Oh my God, that's incredible.
Oh, yeah.
Now we're surrounded by some interesting artifacts here. Tell me what we're looking at.
So right now we're actually in the Cold War exhibit. So again, with the museum, when people come in, they're greeted with the periodic table of elements. But when they start going, usually to the right, it's history. So telling the story of the atomic age, really where it began, which was in so many ways New Mexico. So it's the Manhattan Project, it's Trinity site, and then moving through history into Cold War.
Well, I noticed that there are also lots of pieces on display outside.
Oh,
Heritage Park, did I see it was
Park.
Tell me about that.
So Heritage Park is our 9-acre outdoor exhibit area. We have artifacts, our largest artifacts are out there, such as our B-29 Super Fortress. So that is the same type of airplane as the Enola Gay that ended World War II. And there are actually only 17 of those airplanes left in existence for public viewing, and we have one of them. We have a B-52B Stratofortress. We have fighter jets such as an F-16 Fighting Falcon, an F-105 Thunder Chief. We actually even have a nuclear submarine sail out in Heritage Park, and people often ask, well, is there a whole submarine underneath?
Yeah.
And it is not, but it's just the subsail. And we also have a replica of the Trinity Tower, which was used to hold the very first atomic bomb detonated in 1945 in White Sands, New Mexico.
So why was it a tower? Was something being raised up?
The Gadget. So the Gadget was the secret code name of the very first atomic weapon ever created in Los Alamos during the Manhattan Project. Okay. And they took that and took it out to the White Sands Missile Range in New Mexico, and they hoisted it up this over 100-foot steel tower and put it in a shed. So it's a little shed at the very top. They put the bomb inside of it through a hole underneath, and then they went very, very far away. They went at least 10 miles away. Yes, pretty much. In order to record it via photography to see how did it look when it detonated. So it was a shed that was only 3-sided. One side had a drape that they would take down so they could see it from very far away and then detonate. The world's first testing of the world's first atomic bomb.
Oh my gosh.
Yes.
Well, are there missiles out there too? Or?
We do. We have missiles, we have military vehicles, along with all of the airplanes, the Trinity Tower, and the nuclear submarine sail.
So we're in World War II. We get wind that Germany might be doing some research in nuclear energy. Tell me, where does all this start?
Well, it does start in Germany. You know, there are lots of physicists who are working in California and at MIT and in Cambridge in England and in Germany and Göttingen, and they are determining that, as Einstein's theory says, if you could split the atom, you would release an immense amount of energy. You know, he said that in his theory. No one did it. No one could do it. But then, to everyone's surprise, in 1938, it happened.
Before World War II, okay.
Right as World War II was beginning.
Okay.
And it was in Germany. And so the scientific press learns of this, and they determine, obviously, that you could figure out how to make a bomb out of this, and causes a giant concern among the physicists of the world that this could become a bomb. Right after that, and it had been proven, the United States becomes worried about it, and the scientists principally. And so several of them, Leo Szilard and a number of very prominent scientists, want to write to the president and tell him to watch out. You need to be concerned about this. And they enlist the most well-known scientist on the planet at that time, and that's Albert Einstein. So they write a letter telling the president this has occurred and that this is an issue. And they ask Albert Einstein to sign it, and he does. And so he signs it, and it goes to the president, and the president replies and begins an early effort to start to understand this technology and work with this theoretical physics.
And uranium is a big component, correct?
Uranium is the fissile material that the Germans were working with. They split a uranium atom. And so uranium is not everywhere, and it does take some effort to extract it and to purify it and to enrich it so that it can be capable of being a weapon system. And so that's one of the issues that they begin to figure out as the Manhattan Project cranks up. And they're getting the uranium from a place called the Belgian Congo, which is in Africa, and it's where the mines are. And so they're getting good uranium there. And uranium is an interesting material because there are two isotopes that exist within it, and the one that they need is very rare. There's only a little tiny bit of it in the general uranium that is mined. So they have to take that part out, they have to split it from one to the other, and they're the same thing. They're only slightly isotopically different. Wow. And then they've got to enrich it. And so they're trying to do that, and they're trying to create a reactor in Germany, and that's as the United States begin the effort to do the Manhattan Project And it begins mostly here in Albuquerque.
I was going to say,
and
enter.
then on up to Los Alamos. Yes.
Now, let's talk about Los Alamos. Who was there?
Well, there wasn't anything there at the start of the war except for a slowly fading boys' ranch school. The United States was looking for a place to create the Manhattan Project's places, and there was a fellow who knew about that site, and he was an early person who was part of the leadership. He became the leader of the laboratory there. His name was J. Robert Oppenheimer. And so he took General Leslie R. Groves up on top of the mesa where that boys' school was, and they said, this is the place. We can defend it, we can secure it, and it will be hard for people to get to it.
And how far is it from Albuquerque?
It's about 2 hours from here.
Okay.
It's only a little less than an hour from Santa Fe.
I see.
So Santa Fe is the capital, and Santa Fe is the closest town, although it's much smaller than Albuquerque. But this is where they started, and then they went up that way.
So at this point, the race is on. We don't know, Cold War is involved here, there's espionage, there's all sorts of things going on. Even Moscow is involved, correct?
Well, okay, so in World War II, the Soviet Union is an ally of the United States. So the Soviet are our friends, and the scientists that are coming into the Manhattan Project, many are those that are Jewish, and they're fleeing Nazi aggression in Europe. They're emigrating to places like Norway or to England, and some of them all the way to the United States. So here in New Mexico, this is where the laboratory is chosen to set up to be the brains of the Manhattan Project. Now, they do other work in other places like Chicago and then in the other secret cities as it gets going. But as it really just starts out, it's Los
here.
Alamos, New Mexico.
Well, let's talk a little bit about those secret cities. Why were they secret? People were living there. They knew research was going on there, but they needed to be quiet.
It's a very interesting part of this whole story in that there were cities built. Now, as the Manhattan Project began and got started, they needed to build up an industrial level capability to make the things necessary to make the bombs work. The materials to create them were very rare and hard to do. So they proved that they could do it at Los Alamos, but they needed to just make these giant places to create a massive amount of it for the war effort.
So how many locations were there at that
Well, there were
point?
3 secret cities during the Manhattan Project. One was Los Alamos.
Right.
So that's where the big lab was.
The main,
That was the brain trust where they did all of the research. The next was Oak Ridge, Tennessee. And Oak Ridge was a very sort of rural part of the eastern mountainous region in the Appalachians. And it was chosen because of a couple of things. One, the ridges were long and thin and they were parallel. So you could build plants in each of these valleys. And if there was an accident, it would protect the others in the other valleys from any impact.
And contain it.
And contain it.
Yeah.
There was also electricity necessary. One of the things about the Manhattan Project was it took an immense amount of electricity.
To get the power out there,
That's right.
too. Yeah.
They say that 1/7 of the electricity generated in the United States in those years went into this. No one knew it.
Whoa.
So these cities were so secret that Congress didn't know they existed.
Oh my God.
So people didn't know. So
Were they
built-
all employees though in the city,
Well,
Jim?
many
or-
of them were contractors to U.S. federal government and Army people.
And their
'Cause the-
families would be there with them?
Yes, yes.
And not know what was happening?
What they didn't know what they were doing, what they were making. It was so compartmentalized that they didn't know what they were doing. Wow. So there are these cities that get built and they're very secret. And this is an army bases essentially that these are. So Oak Ridge is set up, and what their role is to enrich uranium to 90% so that it could be made into a fissile material for one of the bombs.
I see.
There's another one that's made in the west area, and it is in Hanford, Washington State. The Hanford Reservation is near the Grand Coulee Dam, and some of the big hydro plants out west provide the electricity. So there they build a massive reactor to create another kind of material needed during this, and that is a special element called plutonium.
Which brings us to this incredible exhibit that you have here at the museum.
So this is a wonderful depiction of what it would have been like to be at the Los Alamos laboratories, special areas during 1945 as the scientists were figuring out the fissile nature and what's called criticality for plutonium. See, there were two different bombs that were made for the Manhattan Project because we used two different bombs with two different fuels to end the war. One was very simple. It was called Little Boy.
Which I know you have on display here.
We have one here, and these are concurrent copies, so they're not like models made later, so they're from the time. And so Little Boy used enriched uranium. Fat Man was the implosion bomb, and it didn't use uranium, it used plutonium. And it was very, very complicated to make it work. In fact, that's the bomb that was tested only 3 weeks before being used in Japan at a site here in New Mexico called the Trinity Test Site.
Which I think you have a tower here,
We
too?
do. We have the only replica of the Trinity Test Tower. This is a wonderful installation. It's an artistic interpretation by an American sculptor named Jim Sanborn. So what Jim is trying to do in this installation is to depict what it was like in the laboratory in 1945 as they work with this material. Now, it's a primitive time. There's not even, we don't even have transistors. There's not the technologies that we know today. You can see a lot of the equipment here.
I see a drawing board.
Yeah,
I mean,
it's very, slide rules. That's what they're using. No calculators yet. They're using very primitive calculating equipment and actually manipulating material to try and figure out how much of it comes together to make what was called the blue flash. That's the criticality. It was called tickling the dragon's tail. It was deadly, and people were injured, and there was even a death at Los Alamos working with this.
Is this what are these silver spheres that I'm seeing in the back?
The spheres are to represent the internal parts of the Fat Man bomb, which was the implosion weapon. Those are where they're trying to figure out how much plutonium and how do you initiate it and what's the size of it. So that's what these are to represent.
And the casing is around to protect it?
Well, it was to actually reflect the radiation back into it.
Oh, I see. I mean, it's really fascinating. And tell me, what is the area behind you that has the white blocks? I'm assuming more testing.
That's right. So they're trying to determine how the neutrons that are being emitted from the plutonium behave. And some of them are deflected and reflected, some are absorbed. And so that white material represents paraffin, a wax, which is one of the things that acts a little like a dense material, but it's not like lead or carbon or graphite.
It can absorb.
It can. It's somewhat they can pass through. Some of it can pass through. So they're working with all these different kinds of materials.
But they are aware of safety at this point. And
yes.
how did they protect themselves?
Well, they use gloves, they use lead. I mean, you can see from these tables, they have lead bricks set up so that the material is shielding them a little bit from the radiation as they work with it. So it's a primitive way of handling it, but they're trying to do it safely. You know, the United States created the first atomic weapons and the only two ever used in warfare. And they used those to end World War II. You know, we had an ally who were the Soviet Union. Well, the Soviets created their own atomic bomb much sooner than anyone thought. So they became our enemy in that way. That was the beginning of the Cold War. So as the Cold War took off and started in about 1949, we went from having 2 bombs to 22,000 bombs as we built up, and they did too. And we invented newer, bigger, more powerful ones. Some of them got miniaturized, but even more powerful. And they created a very special bomb called the thermonuclear weapon. The Mark 17 was the biggest one the U.S. ever made.
How many pounds was it?
22 tons.
Oh my God.
So big that the B-52, the giant airplane that we have here, that plane couldn't even pick this thing up.
Well, you forget about it. It's got to be transported.
That's right.
Yeah.
This is
Oh
the
my
very
goodness.
first weaponized thermonuclear bomb, and it was giant. So this is some really unique material, and it's never been on display. This broken arrow is the biggest of any of the American nuclear weapon accidents there was. So in 1957, a giant airplane called a B-36, which is 30% bigger than a B-52, the only plane that could lift this bomb because of its weight, is flying into Albuquerque to the big Air Force base here, because this bomb is going to have service done on it. Just like anything else, you have to take care of them. So they're bringing this in to the city, to the Air Force base, to do work on it at the laboratory there, and there's an accident. So as it's coming in on approach at 1,700 feet, coming in towards the landing strip, the bomb bay doors open up and this bomb falls out. In fact, it takes the bomb bay doors right off the airplane, and the plane almost crashes because it loses so much weight so fast that it jumps way up into the air.
Wow.
Well, it recovers and they come around and they land it safely without bomb bay doors. And then there's a giant hole in the ground just south of the airport where this thing lands. No one was there, no one got hurt, but it did make a big hole in the ground. So these pieces were recovered from that, and there's a lot of different things here. There's parts of it that are from the bomb bay itself and the doors. This is lead. Now, none of this material is radioactive. There wasn't any radiation there that was a residual. And no American weapon has ever gone off inadvertently in an accident, but they have high explosives. So they create a lot of heat, and they can spread the fissile material around, and that can be dangerous to people. So they had to clean it up. So this stuff can have, lead is not something you want to handle without gloves. That's why we're wearing them.
Okay.
These are parts from this very bomb accident in 1957. One of the neat things about this accident is that no one knew it had happened. No one knew until 1984.
No one heard it?
No one heard it, and the government covered it up until 1984. And then a Freedom of Information Act was able to get the information, and there was an article in the newspaper here about it. And so then we received these pieces from it for our museum.
Well, there must have been a mass exodus to the area.
Right.
With
Well,
people
now
looking for pieces
it's
like
a very
this, right?
important part of our city now.
Oh,
It's
yeah.
where they film a lot of the movies here in Albuquerque, is right there where this happened. And so it's perfectly clean to be there. But this is really unique material.
This is unbelievable. And you said this is lead. I'm dying to.
It's heavy. Can you pick it up?
No, right? I don't think we could pick it up together. Wow, is that heavy?
And look at it. It almost looks like it was like peanut butter.
Yeah.
Well, it got so hot that it turned into liquid, essentially. And that's why it has that kind of look to it.
Almost looks like a moon surface.
A little bit.
But this piece over here doesn't look like it melted at all.
Well, it wasn't a thermonuclear explosion. It was just a high
heat.
High
Yeah.
heat. So parts of it weren't probably right in it. And this is from the bomb bay door. So this is aluminum from the airplane, not from the bomb itself.
Okay. And that's why you see the little rivet
That's right.
holes in there.
And then these are parts that were the metal outer casing and the parts around the bomb that protect it from heat as it's dropped, or to make the casing capable of withstanding the pressures.
It looks layered.
It is kind of layered. In fact, it's
slate.
called
Yeah.
an ablative material. So this is the outer shell. So this is some of the material that would have been around the actual bomb. Now this is a giant piece.
It's heavy too.
It is heavy. So this thing is somewhere around 25 feet long, and it's as tall as you and I. I mean, it's easily 7 feet around, and like I say, it weighs as much as like 10 SUVs.
Oh, cool.
And if you think about that falling out of an airplane all at once, that's a lot of weight.
Yeah.
Yeah.
The Manhattan Project represented a pivotal point in America's history. It was the dawn of the atomic age. It showcases the allure of science, the brilliance of the collective human mind, and the potentially devastating power of knowledge. Thanks for joining me on Museum Access, where every visit is an adventure. I'm Leslie Mueller. See you next time. Made possible by TFI Envision, the connection to conversion agency. Palomino Restaurant Group, 25 years of creative cuisine. ML Capital Partners, building the businesses of tomorrow today.